Good morning, students. Welcome to the class of physics. In our previous class, we had discussed about the combination of resistances in a circuit, in which we had discussed about series circuit, in which all the resistances are connected with the same wire. In our today's lecture, we will discuss about parallel combination of resistances. In parallel combination, all the resistances connected in the circuit are joined with different connecting wires. That means if one of the wire or more than one of the wires does not work efficiently, then the remaining will work efficiently. In this parallel circuit, there is always drop in a current. And why there is drop in a current? Because the resistances connected in different wires are of different values. And the resistance with more value will have lesser current. And the resistance with lesser value will allow more current to flow through it. Similarly, in our domestic circuit, our whole appliances are connected in parallel. Our different appliances use different value of voltage and requires different amount of current. That is the reason they all are connected in parallel circuits. Even our main supply of voltage has a one fixed value, but that is divided in all the different circuits. In the different circuits, they provide different voltage and different current. Why? Because every appliance has its own resistance in them, according to which they use different voltage and current. You have seen for example, ovens, microwaves have a 3-pin plugs more bigger in size than the 3-pin plugs we use for irons or TVs, because they all have different number of different number of resistance in them, so that they can allow that particular amount of current through them, so that the different appliances can work on different voltage and current. Now, if we say that our oven will work on a smaller switch, which we use for just to iron, that will not work on that, because oven requires more energy or larger amount of current to flow, so that it can produce its heating effect. So that is why our appliances work efficiently on different voltages with the different number or different value of amperes marked on the switches. And all these values depends particularly on the resistance in their circuits. Why? Because we know 220 volts is fixed, that will come through our main supply. And that 220 volt is to distribute in our whole domestic circuit. So current is the important part where we need to produce the different energy cycle. So to produce the required amount of current, we need the required value of the switch to install in the circuit. And that mainly depends on the value of resistance. Next, let give you one more example. You have seen our car's headlights work on one switch, but sometimes one bulb stop its working, but other bulb keeps on working. That means that circuit is also a parallel circuit. Clear? Now let's find how we can calculate the equivalent amount of resistance in parallel circuit. Let's first draw the parallel circuit of resistance. As I have already said, if the resistances are connected in different wires, then it is a parallel circuit. So these are the three resistances we are taking. Let its resistance is R1, R2 and R3. Now I current is flowing through this, and according to the value of R1, R2 and R3, here current is I1, I2 and I3. Here voltage remains the same. So now total potential difference across the circuit, total current I across the circuit will be I1 plus I2 plus I3. According to Ohm's law, I is equals to V upon R. Let's put the value over here. So V upon R is equals to V upon R1 plus V upon R2 plus V upon R3. Taking V common, we are left with 1 upon R1 plus 1 upon R2 plus 1 upon R3. So 1 upon R is equals to 1 upon R1 plus 1 upon R2 plus 1 upon R3. That means in parallel circuit, the equivalent resistance is always lesser than the individual resistance. Clear? And there is always drop in current, but potential remains same. Now we have discussed about the combinations of resistances in a circuit. In our next class, we will discuss how to solve the numericals and how we can find which resistances are in parallel and series in a complex circuit. Thank you.